Triethylene glycol, TEG, or triglycol is a colorless odorless viscous liquid with molecular formula H2OCH2OCH2OCH2CH2OCH2OH. It is used as a plasticizer for vinyl polymers. It is also used in air sanitizer products, such as Oust or Clean and Pure. When aerosolized, it acts as a disinfectant. Glycols are also used as liquid desiccants for natural gas and in air conditioning systems. It is an additive for hydraulic fluids and brake fluids and is used as a base for smoke machine fluid in the entertainment industry. Triethylene glycol is a member of a homologous series of dihydroxy alcohols. It is a colorless, odorless, and stable liquid with high viscosity and a high boiling point. Apart from its use as a raw material in the manufacture and synthesis of other products, TEG is known for its hygroscopic quality and its ability to dehumidify fluids. This liquid is miscible with water, and at a pressure of 101.325 kPa has a boiling point of 286.5 degrees Celsius and a freezing point of -7 degrees Celsius. It is also soluble in ethanol, acetone, acetic acid, glycerin, pyridine, aldehydes, slightly soluble in diethyl ether, and insoluble in oil, fat and most hydrocarbons. TEG is prepared commercially as a coproduct of the oxidation of ethylene at high temperature in the presence of silver oxide catalyst, followed by hydration of ethylene oxide to yield mono, 1-D, 2-Tri, 3, and tetraethylene glycols. TEG is used by the oil and gas industry to dehydrate natural gas. It may also be used to dehydrate other gases, including CO2, H2S, and other oxygenated gases. It is necessary to dry natural gas to a certain point, as humidity in natural gas can cause pipelines to freeze and create other problems for end users of the natural gas. Triethylene glycol is placed into contact with natural gas and strips the water out of the gas. Triethylene glycol is heated to a high temperature and put through a condensing system, which removes the water as waste and reclaims the TEG for continuous reuse within the system. The waste TEG produced by this process has been found to contain enough benzene to be classified as hazardous waste, benzene concentration greater than 0.5 mg/L. Triethylene glycol is well established as a relatively mild disinfectant toward a variety of bacteria, influenza A viruses and spores of Penicillium notatum fungi. However, its exceptionally low toxicity, broad materials compatibility, and low odor combined with its antimicrobial properties indicates that it approaches the ideal for air disinfection purposes in occupied spaces. Much of the scientific work with triethylene glycol was done in the 1940s and 1950s, however that work has ably demonstrated the antimicrobial activity against airborne, solution suspension, and surface-bound microbes. The ability of triethylene glycol to inactivate Streptococcus pneumoniae, original citation, Pneumococcus typi, Streptococcus pyogenes, original citation, beta hemolytic Streptococcus group A, and influenza A virus in the air was first reported in 1943. Since the first report, the following microorganisms have been reported in the literature to be inactivated in the air: Penicillium notatum spores, Chlamydophilus ptomaceae, original citation, meningopneumonitis virus strain Cal10 and psittacosis virus strain 6BC, group C Streptococcus, Type 1 pneumococcus, Staphylococcus albus, Escherichia coli, and Serratia marcescens bizio, ATCC 274. Solutions of triethylene glycol are known to be antimicrobial toward suspensions of Penicillium notatum spores, Streptococcus pyogenes, original citation, beta hemolytic Streptococcus group A, Streptococcus pneumoniae, original citation, Pneumococcus typi, Streptococcus viridans, and Mycobacterium bovis, original citation, tubercle bacilli Revenel bovine type. Further, the inactivation of H1N1 influenza A virus on surfaces has been demonstrated. The latter investigation suggests that triethylene glycol may prove to be a potent weapon against future influenza epidemics and pandemics. However, at least some viruses, including Pseudomonas H5/6, become more infectious when treated with triethylene glycol. References